The paper we choose is about the implementation of randomized algorithms to solve the singular value and the factorization, such as the interpolative decomposition and the CUR decomposition. So in this part, we're gonna to first discuss about the main code of the randomized SVD method. So randomized SVD method can be broken into three main steps. First, for any given n by n matrix, we need to first store the row and the column in the matrix. And then we need to generate we need to first impose a target rank k, which k the range is minimal less than the minimal and n. And then we need to generate a Gaussian random matrix omega with the size of n by k. This omega we will use in this next step. After we generate the omega matrix and we need to compute our new n by k matrix y by multiply the original A matrix with the omega matrix. And then we will apply the QR decomposition to the matrix Y. Here we can see that the QR method is a package in the R, so we will not discuss it here. After we do the QR decomposition, we will store the Q matrix. And then the second step, as shown in the figure, is to derive K by N matrix B by multiplying the transpose Q and the original A matrix. And then after we get the matrix B, we will imply the SVD method to get the result. Here we can also see that the SVD method is also a package in the RStudio, and we just imply it. And after we do the SVD method, we will get the left single vectors, diagonal vectors sigma, and the right single vectors. This is the three part of the formula in the SVD method. Here, instead of computing the SVD of the original matrix A, B is a smaller matrix to work with. So for the fact that the singular values, these sigma values and the rectangular values of the matrix B, these two parts are also the singular values and right singular vectors of the original matrix A. So we will just preserve these two methods. And then in order to get the left singular vectors of the matrix A, we need to compute again the left singular vectors of the matrix B. So in this case, we will do this. We will combine the matrix Q derived in the first step with the left singular vectors of matrix B. This is U. And we can get this M by K U matrix. This is the left singular values of the matrix A. So as in this case, we can get the results of the randomized SVD method, which is get this U, get this sigma, and get this right singular vectors. And this can be used to display the in functions that of my group member will talk next.
Then we compress the image using RSVD method. Here we have two images. One is the original unprocessed image, and the other is a reconstructed image. Then we put the two images together here. We can see that the image on the left is unprocessed, and this one is much clearly than the one on the right. Then we use the micro benchmark method to test and compare SVD and RSVD data transmission capabilities. The results are graphed, and you can see this one is RSVD uh, time, spending time, and this one is SVD spending time, and RSVD it is clearly that RSVD is much faster than SVD. So the RSVD package provides one of the fastest routines for low rank matrix approximation in R. And the singular value decomposition plays a central role in data analysis and scientific computing. The SVD is also widely used for computing principal component analysis and linear dimensionality reduction technique. Uh, Randomized principal component analysis uses approximated singular value decomposition to compute the most significant principal components. This package also includes a function to compute robust principal component analysis. So this is the main content of this paper and the code analysis. Thank you for listening.